The unit is about double indicator titration, and this session is looking at the discontinuous method. Let's look at our objective. By the end of this session, you should be able to determine the concentrations of sodium carbonate and sodium bicarbonate in a mixture using the discontinuous method. This time around, we are going continuous. Now, in this titration, the acid is titrated against 20 or 25 cubic centimeters of the mixture using phenolphthalein indicator until the endpoint is reached. The acid is again titrated against 20 or 25 cubic centimeters of the mixture using metal orange indicator until the endpoint is attained. In this type of titration, we don't add the second indicator to the resultant solution from the first titration. We have to pick a new solution and then add the second indicator. So let's look at an example here. An experiment was designed to determine the composition of a sample of clay by double indicator titration on a solution made by stirring clay in water. A is 0.1 molar HCl. B contains the carbonate and bicarbonate species and other inert substances made by stirring 4 grams of the clay in water. Okay, before we proceed, it's just the calculations will be simple, but we would have to determine the volume of the acid that would react with the carbonate and then volume of acid that would consume the bicarbonate. Put A into the burette and perform the following. Pipette 20 or 25 portions of B into a conical flask and titrate it against A using phenolphthalein indicator. Repeat the titration to obtain consistent values. So you see, in this instruction, they didn't say that we should add the other indicator to the resultant solution, an indication that the titration is a discontinuous one. Pipette another. So this is a fresh solution again. We'll pipette 25 into a conical flask and titrate it against A. This time around we are using metal orange. Write ionic equations of the reactions taking place in the titration, and we have to calculate the mass concentrations of the carbonate and bicarbonate. And after that, we have to determine the percentages of the carbonate and bicarbonate in the 4 grams of the clay sample dissolved in water. And hence we have to tell whether the clay will be an effective medicine. Okay, so let's proceed. And these are the tables that we should use: phenolphthalein titration and metal orange titration. We need to complete the tables and find our average volumes of acids. For the first one, as usual, we find differences. We take consistent values. That is 9.5. This is far more than plus or minus 0.15. So 9.5 plus 9.5, we divide by 2 to get the average volume of acid used. Let's label this one as V1 and the volume of acid at the metal orange endpoint as V2. Okay, so the ionic equations, we have the carbonate with the hydrogen ion from the acid. So that gives us the bicarbonate ion. Remember, this is still a partial consumption of the carbonate. So half of this has reacted to give us this. In other words, the phenolphthalein indicator was not enough or couldn't wait for the whole of this to be consumed before it changed color. So at the phenolphthalein endpoint, we have half of this reacted to give us the bicarbonate ion. At the metal orange endpoint, the ionic equations are, so we have, because this time around we didn't use the resultant solution, we have fetched another new solution, and in the new solution we still have the carbonate ion original, and then we have the bicarbonate ion, and then we have the carbonate ion. They are all present. So at the phenolphthalein endpoint, we have the protons from the acid reacting with this bicarbonate ion to give us carbon dioxide and water. There is complete neutralization. And we have the carbonate ion with the acid, also carbon dioxide and water. There is complete neutralization. Okay, so the next, before we can find either concentration, amount concentration or mass concentration for whatever it is, we need to know the volume of acid that was used. Okay, but to do that, we need to understand the various reactions that occurred at each endpoint. We have already said that at the phenolphthalein endpoint, it is only half of the carbonate that will be consumed. So we have this bicarbonate ion. Okay, so only half of carbonate react to give the bicarbonate. We have labeled the volume of acid used here as Phen1. So what this means is that half carbonate ion is equal to Phen1. That's what we have here. So this is just half of the carbonate ion, and that gives us this. So to know the volume of the acid that would completely neutralize the carbonate ion, we need 2 times Phen1, and that gives us 19.0 cubic centimeters. This is the volume of the acid that completely neutralizes the carbonate ion. So we have to go to the concentration of the acid, take our interpretation from there, so we can get the corresponding moles, and we use our mole ratio to get that of the carbonate. We're given concentration of the acid as 0.1 mole per decimeters cube. So if 1000 contains 0.1, then 19.0 would contain 0.0019 moles. This is the moles in the 19.0, and it is this volume that reacted with the volume of the carbonate. So we need equation of reaction to get the mole ratio, and from this equation of this balanced equation of reaction, the mole ratio is 2:1. So if 2 moles of the acid would require 1 mole of the carbonate ion, then 0.0019 moles of the acid will require 1/2 times 0.0019 moles of the carbonate, and that gives us 0.00095 moles. This is the moles contained in the volume of the mixture that was pipetted, the volume of the carbonate in the moles of the carbonate in the volume of the mixture that was pipetted. So if 25 contains 0.00095, then 1000 will contain what? When we do this, we are going to get 0.038 moles per cubic decimeters of the carbonate. So this is the amount concentration of the carbonate, but the task was to find the mass concentration. We wouldn't be able to do that without this amount concentration. Now that we know this amount concentration, we know that there's a relation between amount concentration, mass concentration, and molar mass. So we proceed to look for the molar mass of the carbonate. That is sodium of this carbonate. So carbon is 12, oxygen is 16. So we have 3 atoms of oxygen, so 3 here. The molar mass is thus 60 grams per mole. Now that we know, we go for the relation rho, or mass concentration, is equal to molar mass times amount concentration, or molar concentration. We know our amount concentration, that's what we have worked for, and then we know the molar mass, that is 60. So we put them in, and we have 2.28 grams per decimeters cubed. Up to this point, you could have used the other method and you get the same answer. Okay, so we are done with the carbonate. Let's look at the bicarbonate. Now, to do that, since it reacted at the metal range endpoint, we need to visit that point. And for the metal range endpoint, this is what happened. We had the bicarbonate reacting, we had the carbonate also reacting. So the volume of the acid that was used at the metal range endpoint was actually the volume that fully consumed the carbonate ion and also fully consumed the bicarbonate ion. Interestingly, we have already established a relation for the carbonate ion, and we established that the carbonate was 2 times the first volume of the acid, that is the volume of acid at the phenolphthalein endpoint. So we do a substitution. We go for this 2 times V1 in place of this carbonate, and we have it here. So 2 times V1 plus the carbonate ion gives us, plus the bicarbonate ion is equal to V2. So we take this 2 times V1 to the other side. We do our substitution, and we have 5 cubic centimeters. Remember, this is coming from the volume of the acid at the phenolphthalein endpoint, and this is the volume of the acid at the methyl range endpoint. Alright, now that we know the volume of the acid that completely neutralizes the bicarbonate ion, we can convert it into moles considering the concentration, and use mole ratio to find that of the carbonate ion. So if 1000 contains 0.10 moles, then that 5 cubic centimeters will contain 0.0005 moles. We know these moles, and we have to use these moles to find the corresponding moles of the carbonate. But in doing so, we need the equation of reaction. And this is the equation of reaction. The bicarbonate reacts with the acid to give us the water and carbon dioxide. The mole ratio is 1:1. If that's the case, then we can say that most of the sodium, the carbonate ion, the bicarbonate ion is also 0.0005. Alright, if the moles of the bicarbonate is 0.0005, then that is the moles in the 25 cubic centimeters that was pipetted. But we want the amount concentration that is in dm cubed, 1 dm cubed. So we have to convert this one, the volume with this moles, into 1 dm cubed. We could have used C is equal to N over V, where this is our N, 0.0005, and then the volume is here. We would have converted this one to dm cubed, then divide, we'll get our answer. But we are still using the first principle. So if 25 is equal to 0.00005, then 1000 will contain 0.02 molar, or moles of the bicarbonate ion. Now that we know this, we are to also find the mass concentration, and we'll do the same thing as we did for the carbonate. We find the mass, the molar mass, that is 61 grams per mole, and we find our rho, or mass concentration, that is amount concentration times molar mass, and doing that we have 1.22 grams per cubic decimeters. For the percentages, we know the total mass of the clay, that was 4 grams. We have been able to find the masses. Remember, if the mass of, let's say, carbonate is 2.28, the mass concentration is 2.28 grams per decimeter cube. It's just its mass, that is 2.28 grams, but the volume is 1000 cubic centimeters. So don't be confused. So this mass here, we divide by the total mass, multiply by 100, it gives us the percentage of the carbonate. And we do same for the bicarbonate. Its mass over the total mass times 100, that gives us 35. Okay, we are to tell whether the clay will be an effective medicine. For the clay to be an effective medicine, we need the combined percentage of the carbonate and the bicarbonate ions to be above 75. So we just have to add them to see if we get 75 or above, and that gives us 87.5. So the clay would be an effective medicine since the combined percentage is more than 75. I hope you enjoyed this lesson. We'll meet again in the next